We're going to use a lot of the properties that we just did of parallel lines to talk about parallelograms. They kind of go hand in hand. Parallelogram are made of parallel lines, so all the properties, the same side interior angles, alternate interior angles corresponding, all those properties apply to parallelograms. Some quick definitions first. A parallelogram is a quadrilateral. Quadrilateral just means that something has four sides. Quad means four. Where both pair of opposite sides are parallel. So if you look at the diagram, segment AB is parallel to segment DC, which means they never touch. And segment AD is parallel to segment BC. The little arrows on the lines mean parallel, means they never touch. Opposite sides do not share a vertex, opposite angles do not share a side. So opposite angles would be D. You have to go completely across the parallelogram to get to its opposite angle in B. And A would be opposite of angle C. Angles in a polygon that share a side are called consecutive angles. You can also call them same side angles. So consecutive angles means they're right beside each other. They share a side. So angle A, which is right here, shares a side with angle D. They share side AD together. So A and D would be considered consecutive angles. A and B would also be considered consecutive angles. B and C would be considered consecutive angles, and DC would be considered consecutive angles. They're right beside each other. So if a quadrilateral is a parallelogram, so if our four-sided figure is a parallelogram, if opposite sides are parallel, then opposite angles are congruent. That means my angle at A would be equal to my angle at C. So whatever A is, C has to be. Whatever my angle is at D has to be equal to the angle at B. So opposite, you go across the figure. A is equal to C, D is equal to B. Next, if a quadrilateral is a parallelogram, then consecutive angles are supplementary, which this makes sense. Because if you think about it, we have parallel lines here and a transversal. So if we're looking at these two angles, right, they are inside my two lines, and they're on the same side of my transversal, which makes them same side interior angles. Right. From last week and previous couple weeks, actually, we have said that same side interior angles are supplementary, so they add up to be 180 degrees. So if angles are right beside each other in a parallelogram, they are supplementary, they are equal to 180 degrees. So that would be A and B. They share a side here, AB, so A and B would be equal 180, B and C would equal 180, A and D would equal 180, D and C would equal 180. So if you have a parallelogram, not only are opposite sides parallel, they are also congruent. So if they have the same amount of arrows on them, it means they are the same measure also. So AD would be equal to BC, and AB would be equal to DC. Exact same length. Opposite sides, opposite angles are the same. Then the last property we'll talk about are about the diagonals. So if we have a parallelogram, the diagonals bisect each other. Now, don't forget what bisect means. It means it cuts it into two equal parts. So my diagonals are the lines that go from opposite angle to opposite angle. Right. So AC and DB would be my diagonals. They cut each other in two. So if I take segment AC and I cut it into two equal parts, that means AE would be equal to EC. And if AC cuts DB into two equal parts, that means E is my midpoint. So that means DE is equal to EB. Right, so diagonals get cut in half. The point that intersects is called the midpoint. Okay, for our first example, there's 1,000 ways you could do this using your properties. we're going to fill in all sides and all angles. First, let's do our sides first. All opposite sides are congruent, so therefore if BD is 22, that means AC has to be 22 also. If AB is 16, that means CD has to be 16 also. Right? Then to do the angles, you could work with opposite angles, you could work with same side angles, however you want to go at it first. I'm going to start with opposite angles because I know that they are congruent, they're the same. So if A is 35, to get to D, I want to go completely across. To get angle D, it's going to be the same thing. So it's also 35 degrees. Okay, and then if I have two more angles I need to get, they're going to be the same degree because they're opposite of each other. Right, but to get that, I have same side interior angles or consecutive angles that add up to be 180 degrees. So I'd want to do 180 minus 35, which is equal to 145 degrees. So if angle C is 145, that means angle B also has to be 145. Go ahead and pause and you try by yourself. Let's do our sides first. Opposite sides are congruent. So if AB is 22, that means CD is also going to be 22. If BD is 30, that means AC is going to be 30. And let's work out our angles. I'm going to do my opposite angle first. If D is 135, go opposite, that means A is 135. And then to get the other two angles, you want to take 135 and subtract it from 180, which would give you 45 degrees. Alright, so don't forget, parallelograms, opposite sides are parallel, opposite sides are congruent, opposite angles are congruent. Consecutive angles or same side angles are supplementary, they equal 180, and diagonals cut each other in half.